Okay, in this example, we're going to compare differentiating a function first by expanding it using the binomial theorem, and then differentiating term by term like we're used to differentiating using the chain rule. So first, let's go ahead and do it the first way. So part A here, we've got this function y equals brackets 2x plus 3 cubed. And so we wanna expand that. So we need to expand 2x plus 3 cubed. Now, if you remember from the binomial expansion, this is equal to combination of three things taken 0 at a time times the first term raised to the third power times the second term raised to the 0th power, plus combination of three things taken 1 at a time, 2x, remember the powers are descending for the first term and ascending by 1 for the second term, plus 2 times 2x to the first power and 3 to the second power, and finally 2x to the 0th power, and then 3 all the way to the third power. Now, just to be sure, our power is n, so we know we're going to have n plus 1 terms, and I see 1, 2, 3, 4, so we're good there. So if you don't remember, you can get these combinations. It's just NCR. You would type 3 and then NCR 0, 3 NCR 1. You can compute those. Or again, recall you can use Pascal's triangle. So if we do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So we know that since we have the power of 3, that's going to correspond to the third row of Pascal's triangle. Now, this kind of looks like the fourth, but remember we call this first row the 0th row, So really, this is our fourth row, which means these are going to be our coefficients of our terms for the expansion. In other words, they're equal to these combinations that we've written here. So I'll keep that in mind as I write this out. So I know that this right here, this coefficient is going to be 1 times 2x cubed. Remember, you have to cube the 2 and cube the 8. So this is 8x cubed. And then 3 to the 0th power is 1, like anything to the 0th power. Plus three things taken 1 at a time. This corresponds to this one from Pascal's triangle, so that's 3 times 2 squared times x squared, that's 4x squared, times 3 to the first power, which is 3, plus, again, 3 here, over here from the triangle, or your calculator, times 2x to the first power, which is just 2x, times 3 squared, which is 9, plus the last one is 1 times 2x to the 0th power, which is 1, and then times 3 cubed, which is 27. Okay, so already that's a fair bit of work to make this expansion, and we still need to simplify, so let's do that really quickly. This is going to be 8x cubed plus, this term is 9 times 4, 36, x squared. That's 6 times 9, 54x, and finally 27. Okay, so just now we're ready to differentiate. We had to do all this work to expand it, to get it into a polynomial that we can differentiate. So let's do that now. So if this is equal to y, well then dy dx must be 24x squared plus 72x plus 54. Okay, so I mean, while that wasn't terribly difficult, it was kind of time consuming. Let's compare that to using the chain rule to differentiate the same equation. So using the chain rule, using the chain rule. So I'll just write my equation down again. It was y equals brackets 2x plus 3 cubed. Okay, so again, the first step is always choosing that middleman u. And again, it's an obvious choice here. So let's choose this inside function. Let's choose u to be 2x plus 3. And then what's nice about that is that y becomes simply u to the power of 3. And now we need to differentiate these. So du dx is just 2. And then dy du is 3u squared. And so now, remember, dy dx is equal to dy du, that's this color, is equal to dy du times du dx, which is going to be just 3u squared times 2. And we can simplify that straight away. That's 6u squared. But again, this is dy dx, so we don't want to leave it in terms of u. So let's change it. Let's substitute back in, remembering that we chose u to be 2x plus 3. So dy dx is 6 times 2x plus 3 squared. And I'm perfectly happy to leave this factorized like this, but for the sake of comparing to what we did before, this polynomial here, let's expand it just to make sure that we get the same thing. So I'll expand 2x plus 3 squared first. So this is going to be equal to 6 times, this is 4x squared plus 2ab, that's 4x times 3, that's 12x, plus b squared is 9. And then we'll distribute. So that's 24x squared plus 6 times 12, that's 72x plus 54. And indeed, you can see we do get the exact same thing. Now, it's really up to you whether you think which example you think is easier or faster, but I would argue, even in this example with a low exponent, I think the chain rule is definitely a bit quicker. Now, if you were to raise that exponent up to something like 5 or 8 or 10 or more, the chain rule is going to be by far the easy choice for differentiating.